Hello students, in today's lecture we would be studying about the various types of switching networks, and this topic comes under the basics of switching systems. As we have studied about the switching system in the previous lectures, let us start with a basic model of a switching system. The figure 1.9a, which is this one, shows the basic model of a switching system. The switching system, which is also called as the exchange, has the set of input and output circuits. These circuits are called as inlets and outlets. For the switching system, which has been shown here, it has n inlets and n outlets respectively. And the primary function of this switching system is to establish an electrical connection in between a given inlet-outlet pair. That means any of the n inlets can be connected to any of the m outlets through this switching system. Switching system, the hardware used to establish such a connection is called the switching matrix or switching network. And students, here it is very important for you to understand that the switching network is the component of the switching system and should not be confused with the telecommunication network. So this is the basic switching system having n inlets and n outlets. And for any connection to be established in between the subscribers, n inlets are connected with m outlets, right? And what is the primary function of the switching system? To establish this electrical connection in between a given inlet outlet pair. The subscriber who would be initiating the call would be at the inlet, and the subscriber for whom the call is destined would be at the outlet. Now, moving on. Figure 1.9a shows a model of a switching network with n inlets and m outlets. When n is equal to m, here, where n is equal to m, the switching network is called as the symmetric network. The number of inlets is equal to the number of outlets. The switching network is called a symmetric network. So anytime when you are asked to define symmetric network, so what is a symmetric network? A switching network with the number of inlets is equal to the number of outlets is called as the switching network. Now these inlets or outlets may be connected to the local subscribers or to the trunks. What is a local subscriber? Within the same city, trunk calls from one city to the another. Right? Now these switching systems in 1.9b shows the subscriber inlets and outlets. These are the local subscribers which are connected through this exchange, and incoming trunks and outgoing trunks means the subscribers are connected via this switching network to some other exchange for trunk connection. Is that clear? Now, in figure 1.9b, 9d, four types of connections. I'm sorry, 9b I'm asking about. In this 1.9b, four types of connections may be established. One, the local call connection between two subscribers in the system. That means one subscriber, which is a local subscriber, can be connected to this subscriber, which is a local subscriber. Second, outgoing call connection between a subscriber and the outgoing trunk. Then incoming call connection between an incoming trunk and a local subscriber, and a transit call connection between an incoming trunk and an outgoing trunk. When it is a local call connection means from the subscriber inlet to the subscriber outlet. Now, outgoing call connection between a subscriber and an outgoing trunk means what? This local subscriber wants to make a trunk call to a person who is connected to some other exchange. So this subscriber would get connected through this system over this line to the other exchange for the trunk call. Similarly, incoming call connection between an incoming trunk, there is some subscriber with some other exchange, and this exchange is getting an incoming trunk call at this point with a local subscriber from the other exchange. And then we have a transit call connection in between the incoming trunks here and the outgoing trunks here, right? So this was figure 1.9b. Now coming to figure 1.9c, we see when all the inlets are and outlets are connected to the subscriber lines, the logical connection appears as shown here. Such type of a network is called as folded network. In a folded network with n number of subscribers, the maximum number of calls which are possible would be n minus 2. The maximum number of simultaneous calls I'm asking. I'm telling simultaneous calls or simultaneous information exchanges. The switching network may be designed to provide n by 2 simultaneous switching paths, in which case the system is said to be non-blocking. Now, what does that mean? The maximum number of calls which are possible are n by 2 and maximum paths are available. So, not in any case the subscriber would be blocked, would be stopped for making a call for the want of resources. What do I mean here? If a subscriber wants to make a call and that the calling subscriber wants to make a call to whom? The called subscriber. Now the calling subscriber makes a call and the called subscriber is not busy. Then in any case the call would be established because the resources are available. Such type of a network is called as non-blocking network. In a non-blocking network, as long as the called subscriber is free, a calling subscriber will always be able to establish a connection to the called subscriber. In other words, a subscriber will not be denied a connection for the want of switching resources. But in general, it rarely happens that all the possible conversations take place simultaneously. It is a very rare situation. And providing maximum number of calls which are possible as a resource into the switching system or a switching network is considered to be the wastage of economic resources. So our design parameters are are taken care of in such a way that the maximum number of resources, the paths which are made available into a switching system is not equal to the to what is actually required, but there are certain design parameters which are taken under consideration to check what is the maximum number of calls which are handled by this exchange at a particular instance of time. And those calls, the number, is taken as the number of paths which are given as a resource in a switching system. And such type of an exchange is called a blocking network. Here we have, there are instances when the subscriber would be blocked. There would be instances when the calling subscriber wants to make a call to the called subscriber is free, but still the calling subscriber is not being able to make a call because the path is not available. आपने बहुत बारी कॉल किया होगा और आपको ये बोला गया होगा कॉल में कि इस रूट की सभी लाइनें व्यस्त हैं. What does that mean? All the lines to the route are busy, the lines are not available, and hence you are not able to make a call. Such type of a network is called as blocking network. And the blocking probability, very important term, the probability by which the user gets blocked. This should be very low for a good exchange. A good exchange design should be such that the blocking probability of the exchange is very, very low. The design parameters should be handled very carefully. All switching exchanges are designed to meet the maximum estimated simultaneous traffic, and that is called as busy hour traffic. And Erlang, it is the unit of traffic. And in telecommunication networks, the traffic is measured by a unit which is called as Erlang. A switching resource is said to carry 1 Erlang of traffic if it is continuously occupied throughout a given period of observation. Now, we have discussed about the basic model, then the inlets and outlets via 4 connections which are available, then a folded network, and then we have just now discussed about what is a blocking network, what is blocking probability, what is busy hour traffic, what is a non-blocking network. Moving ahead, we can now discuss about a transit exchange or a non-folded network. In a switching network, if all the inlets and the outlets are used for inter-exchange transmission, there are no local subscribers connected here. The type of network is called as transit exchange or the transit switching system and is called a non-folded network. And in this non-folded network, since we have incoming trunk lines means what? All the connections would be all the inlets here would be connected to some other exchange. And outgoing trunk lines, all the connections here would be for some other exchanges. So this is called as the transit exchange, and the number of simultaneous information transfers which are possible here are n. So all the definitions which have been discussed in this lecture are very important from examination point of view, also for you to understand the next topics. You should be well aware of these terms, because now onwards we'll be using these terms very frequently, and you should be able to understand when I say that it is a folded network or it is a non-blocking network. So I hope you have understood this lecture thoroughly. Go through the lecture and we'll meet in the next lecture very shortly. Thank you.